So, in the previous classes, we've discussed mutually exclusive events. We've discussed for this class, we're looking at what we refer to as combined outcome or independent events. Now, what does this mean? What does this mean? It means that when you have an independent event, what it means is that the result, if you have two separate events happening, the result of one event does not prevent the result of the other event. Both of them would have a different outcome. That's what it's telling you. That you'll be having a different outcome. So one outcome does not prevent the outcome of the other. So let's write the note on it. When two events happen, the outcome at the same time, and the outcome of the first event does not prevent the outcome of the second event from happening. Then both events are said to be independent events. They are said to be what? Independent events. They are said to be independent events. And most times, for us to solve questions on it, we need to make use of what we call the AND solve questions on it. We need to create what we call a sometimes we need to create a tree diagram. We need to create a tree diagram to solve questions pertaining to it. Most times we would, in order to solve questions on it, a tree diagram or space diagram is required. Now, okay, let's quickly write these notes. I'll give you a moment to write the notes. Outcome of tossing two coins. List all the possible outcome of tossing two coins at the same time. Find the probability of getting at least a tail and B, getting two heads. Now look at this question. It's very interesting. You have two coins. You have two coins. Unfortunately, I don't have any coins with me here. But you know something, that if you have a coin, one coin, your coin will either have head or tail, isn't it? That is, one face of the coin will be head, while the other face will be what? Tail. Abi? Now, this is the first coin. Now, the second coin to the same thing. The second coin is either it has head or it has tail. Now, And I take those 2 coins. Unfortunately, I don't have a coin with me here. I would have explained better. I take those 2 coins, I throw them up, and they fall to the ground. There's a possibility that in the first throw, I can have head. In that same throw that I've thrown it up, I can have head, tail. In that same throw that I threw again, it's possible that I will have tail, head. And that same throw that I threw, it's possible I have tail. I don't know if you are getting what I'm saying. When I threw that coins, what I could have gotten, it's possible that for the first coin, I would have gotten head, and the second coin, I would have gotten head. It's possible that that time that I threw it, I could have gotten head in the first coin and gotten tail in the second coin. It's also possible that that time I threw it, that I got tail and I got head. And it's also very possible that that same time that I threw it, I got tail and I got tail. So this is a list of all the possible form of outcome that I can get. That is what it is telling you. That this is the possible form of what outcome that I can get. So if I want to do it in space diagram, that means what I'm telling you is this. That means I could get head. So you can do it this way. I could get head, tail. I could get tail, head, and I could get tail. That's what it's telling us. So these are the possible outcomes that I can have, which is what? 4. Isn't it? I can get these 4 possible outcomes. Remember what I told you in the last class, that your probability is a function of what? The number of successful trials all over what? Number of what? Possible trials. The number of successful trials all over what? Number of what? Possible trials. So looking at this, what's the probability? So these are, what's the probability of getting at least a tail? At least. Now, in English language, what does that mean? At least a tail. So let me write this out here. Number of possible outcome is equals to what? Is equals to 4. Why? You have this, you have this, you have this, you have this, which is this, or this. Now, for the first one, we said probability of getting at least 1 tail. Now, in English, I don't say at least 1 tail. What does that mean? What does that mean? At least 1 tail. It means that it could be more than 1, right? It means that the number of tails could be more than 1, but it should not be less than 1. That's what it means. So now if you look at this, you have a tail here, so this is correct. You have a tail here, this is correct. You have 2 tails here, which is also correct, because they said at least 1 tail. So what's the probability of getting at least 1 tail? This place, for you to have this is 1/4, this is 1/4, and this is 1/4. So meaning that if I do it, there's a probability that I will get 3 tails. So there's a probability that my number of successful outcome will be what? Will be equal to 3. That is what it's telling you. To be 3. At least to occur here, to occur here, to occur here. So therefore, my answer will be what? 3/4. That is the answer there. Probability of at least 1 tail. Now, the next question. They said probability of getting 2 heads. 2 heads. Like I said, the number of possible outcomes here could be head, tail, head, tail. Now, they're not only that getting 2 heads. That means they are restricting you already. Your number of successful outcome is 1. You can only get 2 heads. Once. Are you following me what I'm saying? And even they said probability of getting a head. Then you know that you get head here, get head here, get head here, you won't get here. Probability of getting at least a head is 3/4. Probability of getting 2 tails is what? 1/4, because you can only have 1 tail. That is 1 tail. So that's what is also happening here. You can only have 1 2 head. So that will be 1/4. Very simple. So the next question: a fair die, a fair coin, and a fair die are thrown at the same time. Are thrown at the same time. At the same time. Full stop. List all the possible outcome. List all the possible outcome by making a possibility space diagram. A possibility space diagram. Roman figure 2. A tree diagram. Remember I told you something in the initially, that if you want to solve questions on independent events, that you can always use a space diagram or a tree diagram. Now, this one that we did here was a space diagram in order to solve this question. A space diagram. You just think of all the possible outcomes that we can get, and then we use that. Then we now have the next question. They said, what is the probability? What's the probability of getting Roman figure 1, head and 5, Roman figure 2, a tail and odd number. A tail and odd number. Now, let's take a look at the question again. Look at the question. It said, a fair coin and a fair die are thrown at the same time. You have a fair coin, a coins in one hand, a die in another hand. Unfortunately, it's so painful. I don't have any of these things there. A coin in one hand, a die in the other hand. Now, you throw the both of them at the same time. Of course, whatever you get on your dice would not be determined, or will not determine, or will not affect what you get from your coin. It will not. Isn't it? So now that is what we are asking you. What is the probability of getting this? So the first we need to do is to make our possibility space diagram. So I'm going to explain that to you. Now, when you're making your possibility space diagram, what you need to do is just having something like this. Something like this. Now, this is your die. This is the aspect for your die. And this is the aspect for your coin. Now, what are the outcomes you can get for your coin? Your coin can be head or tail. So this is your head, this is your tail. This is your head, this is your tail. Look at your possibility diagram. This is coins. This is dice. Now, for your coin segment, your coins can only give you head or tail. You highlight it here. Now, what can your dice give you? Your dice can give you 1, can give you 2, it can give you 2, it can give you 3, it can give you 4, it can give you 5, and it can give you 6. Now, meaning that at your first row, it's possible you get head and 1, or tail and 1. You could get head and 2. You could get head and 3, head and 4, head and 5, head and 6. Yeah, tail and 2, tail and 3, tail and 4, tail and 5, and tail and 6. So look at all of these. This is what we call a possibility space diagram. That's all. Once you've done this, you've gotten your full mark. Now, the next question said you should make what we call a tree diagram. Are you getting me? For your tree diagram, please, I'm sure we've written this question down. So I'd just like to, because we only need to look for tree diagram, yeah? So I'd just like us to rub this off so that I can show you a tree diagram for this question. Now, your tree diagram has to do with you splitting events. You split your events into 2. Your first event, your second event, and your outcome. Now, what do I mean? I have my first event. I have my second event. And then I have my outcome. It's as simple as that. First event, second event, outcome. Now, what's my first event? My first event is the coin. That will make it easier. And my second event is the die. This will make it easier. And this will be my outcome. Now, from my coin, which is this, I can get, let me bring it down a bit. From my coin, I can get head, or I can get tail. You know, when you toss your coin, it's either you get a head or a tail. So this is where you have it. Now, from my second event, which is die, I can get 1, I can get 2, I can get 3, I can get 4, I can get 5, and I can get 6. The same thing. I can get 1, I can get 2, 3, 4, 5, and 6. Now, what my outcome table will now be is this. This is outcome. My outcome table will tell me that, okay, this is head and 1. That means I can get head 1. I can get head 1. I can get head 2, head 3, head 4, head 5, head 6. For this part, so I'm done with the outcome here. For this part, I can get tail 1, tail 2, tail 3, tail 4, tail 5, and tail 6. That's what it's telling me. So you can see that the answers I got here are the same thing as the answers I got here. So this is your tree diagram. Why the other one is your what? Is your possibility space, or you can just call it for short. You can call it space diagram. Do we have questions there? No. Now, the next question, B. They said, what's the probability of getting H pi? I mean, it is very, very possibility of you getting H pi. How do you get H pi? Now they are asking you. H pi. What did you say? The probability of getting what? H. Probability of getting H pi. That is the next question. So let me just draw this out so that you don't confuse yourself. H5. Now if you look at it, what's your number of possible outcomes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. If you come here to the same thing, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means your number of possible outcomes, let's just write it here. Your number of possible outcome is equals to 12. Is equals to 12. So now, how many times do you have H5 appearing? You only have it once, which is here. Is H5 appearing once? H5 is only appearing once. So probability of H5 is what? 1 over what? 12. That's your answer here. 1 over 12. Now, they now ask another question. The next question is what? Probability of a tail. So probability of a tail, that is one tail, and odd number. You have a tail and odd number. Now it's very simple. You come to your outcome table. It's either you come to this space diagram or you go to this one. Anyone. Odd number and a tail. So first and foremost, it must be a tail. Abi? Now if you look at it, everything you have here are tails. So odd numbers. 1 is an odd number, 3 is an odd number, and 5 is an odd number. So the only ones that fit the description are T1, T3, and T5. And how many are they like that? 1, 2, 3. So that means you'll be having a tail and odd number. You're having 3 over what? 3 over 12. That'll be 3 over 12 because you have a tail and odd number for T1, a tail and odd number for T3, and a tail and odd number for T5. So this is going to become 1 over 4. To the lowest term, this is 1 over 4. So that brings us to the end of this topic, probability.